Hello everyone, welcome to my channel. If you're new to this channel, please support us by subscribing and sharing these videos with friends. Now in this video I have this integral to look at. It's the integral of x squared minus 1 dx. Now whenever you have a quadratic expression under the squared sign, just know that we're going to use most likely the trig substitution. Now if I had x outside here, I would have used u substitution because the derivative of x squared minus 1 is 2x. With x out, it would have worked using u substitution. Now there's no x outside here, you only have x squared minus 1 under the squared sign. So we have to use trig substitution. Now you must remember that when we have the x squared term in the first place minus some number there, it's the sec substitution. If you have some number here, x squared this side, or an expression containing x squared this side, then we would have used what we call the sign substitution. If I had a plus sign here with these terms like that, I would have used the tan substitution. So familiarize yourself with the suitable trig substitution that you're supposed to use. Now in this one, we're going to use the sec substitution like I said. So we approach it as follows. Let me capture the integral first. So it's the integral on page 1. It's the integral of the square root of x squared minus 1, and then we have dx. So like I said, we're going to let sec theta be equal to x. That will be the starting point. So let sec of theta be equal to x. Now from here, the first thing we have to do is to look at what does this mean. In terms of secant, we know that this can be written as x over 1. By definition, if we use a right angle triangle, this would be hypotenuse over adjacent side. Now let's look at the right angle triangle I'm talking about. Suppose this is what you have, and your angle theta is this one here. By definition, secant is the hypotenuse over the adjacent side. Now we need to use Pythagoras theorem to work out the opposite side, and you'll agree with me that it will just be x squared minus 1 squared, which is, we take square root of that, obviously it will be square root of x squared minus 1, because x squared of course is x squared and 1 squared is 1. So that is the first part. And the second part would be to differentiate both sides of this equation here. So that is part 1. Part 2 would be to differentiate with respect to x both sides. Derivative with respect to x of sec theta must be equal to derivative with respect to x of x. Remember, we're looking at this equation here. Now on that part here, we're going to use chain rule, and you should remember or recall that derivative of secant is sec tan. So sec theta times tan theta, and then we're going to say d theta dx. On the right hand side, of obviously derivative of x with respect to x is just 1. Multiply by dx both sides, we get the expression in terms of expression for dx as follows. So this is going to be sec theta tan theta d theta will be equal to dx. Wonderful. Now, so we are basically saying this integral now can be transformed as follows. We have the expression for x, we have the expression for dx, as you can see here. Right, so now we're taking this to page 2 as follows. Right, page 2, we are now saying that the integral, we're now saying therefore the integral of the square root of x squared minus 1 dx is equal to the integral of the square root of, remember instead of x I'm going to put sec, because x equals sec, as you can see x equals sec theta. So what I have there is, if you agree with me, what I have there is sec squared of theta minus 1, and outside here we can have sec theta, tan theta, d theta. As you can see over here, the expression in terms of sec and tan for dx, this is what we have. Now I want to remind you of something here. If I can get a page here, a separate page, I want to remind you of some trig identity that we use to deal with the, I'm going to use, let me just use some page from here. If I can grab a page from here. If you recall, and I keep reminding you this one in most of the videos, that we are going to use the trig identity sine squared of theta plus cos squared of theta is equal to 1, and we divide throughout by cos squared of theta, assuming cos squared of theta is not equal to 0. We have sine squared of theta over cos squared of theta plus cos squared of theta over cos squared of theta equals 1 over cos squared of theta. And like I said, we're assuming cos squared of theta is not equal to 0. This is just tan squared of theta because sine over cosine is tangent. Plus, obviously, you can see that's 1, and this is your sec squared of theta. Now, if you can remember or see, here we have sec squared of theta minus 1. So I'm going to take subtract 1 from both sides, or take this one to the other side. So we're going to have tan squared of theta is equal to sec squared of theta minus 1. Obviously, if you subtract 1 from both sides, this is what you get. So where I see this, I must just put tan squared of theta. Now we are saying basically that this therefore is the integral of the square root of tan square root of theta times sec of theta tan of theta d theta. Wonderful. Now this cancels that, as you can see. So what we have now is the following. We now have the integral of tan theta times sec theta times tan theta d theta. Now rewriting this, it simplifies to the integral of tan squared of theta times sec theta and then d theta. Fantastic. Now what we need to do now is, I'm going to call this one I. I'm going to call this one I. Notice that this is just our original integral, but in terms of trig expressions. Now, so now I'm going to say let I be equal to the integral of tan squared theta times sec of theta d theta. You'll understand shortly why I'm doing that. So I'm going to say, therefore, what it means is I is going to be equal to the integral of tan squared. Instead of tan squared, looking at this expression here, I can replace tan squared by that expression. So what I have now is sec squared of theta minus 1 times sec theta d theta. Over here, as you can see, is what I get. Continuing, we have the integral of distributing sec theta and d theta throughout, and the integral, we have the integral of sec cubed of theta d theta minus the integral of sec theta d theta. Now, you should recall by now that the integral of sec is just the natural log of sec plus tangent. So, and I'm going to represent this by some other integral sign. So let's say this is equal to I1, and then I'm going to say minus the natural log of sec theta plus tan theta. You should remember now that the integral of secant is just that one. Now I have to work out this one here, which I call I1. So I'm going to say I1 is equal to the integral of sec cubed of theta d theta. I'm going to split this one now. As you would imagine, I would have to split that into sec times sec cubed, times sec squared. So this is the same as the integral of sec of theta times sec square root of theta d theta. Wonderful. I'm going to use what we call integration by parts now. So if I can just start from here, I'll continue on the next page. At this point, I'm going to let u be equal to sec theta. And then I'm going to let dv equals sec squared theta d theta. As you would recall, integrating both sides here, it just gives you v equals tan theta. The integral of sec squared is tan, because the derivative of tan is sec squared. And differentiating both sides here, you're going to get u is equal to sec theta tan theta d theta. Remember, derivative of sec is sec tan. Now, going into integration by parts formula, we proceed as follows. Take you to page 4. We proceed as follows. So the integration by parts, let me put these papers in order. Remember, we're dealing with I1 here now. Integration by parts says the integral of u dv is equal to uv minus the integral of v du. Should remember this by now. And if you look at this part, it's just that part there, sec times sec squared d theta. So we're saying this implies, remember that's our I1. I1 is equal to the integral of sec of theta times sec squared of theta d theta. This is your u and that's your dv. If you remember, this must be equal to uv. What is u? Sec theta. What is v? Tan theta. So this is sec of theta tan theta, and then minus the integral of what is v? Tan theta times what is du? Remember, v du. Du is sec tan. So this is sec theta tan theta d theta. If you simplify this, this is just sec of theta tan of theta minus the integral of, this is tan squared of theta sec theta d theta, because that's tan squared. Now if you look at this one here, is our original integral actually, which we called I. Here it is on page 3. That I here is this one here, which is just that one. So I can say here now comfortably and say that this is the same as sec of theta tan of theta minus I. So this is I1. Where did I stop on I1? And it's here. Remember, this is the place. So I'm going to have I. Remember, I equals this, if you like. I equals this. I equals that expression. So this one here must come into that place. So I'm going to now say, therefore, I is equal to, where are we at? We're here. I equals I1 minus this. What is I1? That's expression for I1, as you can see. Let me capture this the way it is. I1 minus the natural log of, we are here, sec of theta plus tan theta. Now, I told you that this is the same. Now we're done with integration. I must just put this one in that place, do the simple algebra, and then we add a constant of integration. So this is going to be equal to, in the place of I1, I'm going to have sec theta tan theta minus I, and then I'm going to say minus natural log of sec theta plus tan theta, space there. I'm putting absolute value sign there. Of course, you can see that we have sec theta plus tan theta over there. I'll rewrite this expression. So what are we saying? We're saying I equals this. Now this I must come to the left hand side to add with this I here. Now, so what do we have now? What we have is the following. We have the following taking us to page 5. What we have now is the following. If I may put these papers in order nicely. Yeah, this is trig substitution, quite involving, but yeah. So we're now saying this implies I plus I on the left equals sec theta tan theta minus natural log of sec of theta plus tan theta, like this in absolute values, because we know that that can be negative. Now what do we have on the left hand side? We have 2I is equal to sec theta tan theta minus natural log of sec theta plus tan theta, like so, and divide by 2 throughout, we get our solution. I equals half of sec theta tan theta minus half of natural log of sec of theta plus tan of theta, like so. Nice. Where are we coming from? What is our I? Our I, if you check from the beginning, our I is just that integral, and that integral was a simplification of this, as you can see from here all the way up to there. So our I is actually that one. So now I'm going to have to say, therefore, if you allow me to move backwards, therefore the integral of the square root of x squared minus 1 dx is just going to be equal to, we're here, half of sec of theta tan of theta minus half of natural log of sec of theta plus tan theta, and then now I must say plus a constant of integration c. But we're not done. We must revert to our original variable. Now, reverting to our original variable x, we are saying what is the connection between x and theta, taking us to this right angle triangle here. Remember, secant or sec of theta is just x. Tan of theta is going to be the opposite over adjacent, so it will be that over that, which is just that expression. So secant is x over 1, which is x. Tangent is just this one here. Remember that over that, opposite over adjacent is tangent by definition. So this over 1 is the same expression. That over 1 is the same expression. So secant of theta is x, and tangent of theta is the square root of x squared minus 1. So we're going to say now that expression is equal to half of secant of theta is x, tan of theta, like I told you, is square root of x squared minus 1, and then we're saying minus half. The natural log of these two terms are just x plus square root of x squared minus 1, like so, and then plus c. Now you can write this as one expression, this one here, because of the half there, taking us to just complete this on our page 6. Page 6, we're saying, therefore, that expression there, this expression, as you can see, this expression is just equal to, if you like, x square root of x squared minus 1 minus the natural log of x plus square root of x squared minus 1, and then we're saying all over the whole of this expression, all over 2, and then plus a constant of integration c. We know that c is actually a real number, like I said in the previous video, but we're not necessarily going to be bothered by that to say we must say that c is a real number. This is sufficient the way it is. So that would be the final solution to this integral here. This one here, there you have it. One of those integrals that will take a bit of time to evaluate, not very complicated, but yeah, trig substitution, maybe someone can say at its best. I know that we have more complex cases of trig substitution. This is not one of them. Lengthy, but not very complicated. All right. Tell me what you think about this integral. I'll see you in the next one.